So this is the project Existential Forgery Attack on RSA signatures. Now, RSA signatures are very simple mathematically, and therefore they have a lot of vulnerabilities. And what we're going to do here is we're going to sign something with an RSA signature, and then we're going to show that you can forge a message and a signature, where the signature matches the message without knowing the private key, and that, of course, is not good. So now I'm using this crazy Python anywhere because Google Colab was not working. So I need OpenSSL. Let's see if I have it. This is a bash OpenSSL. I do have it. Okay, let's quit. And let's do OpenSSL version. Oh, good. It's got the old version 1.1 that I don't need to downgrade it. That's handy. Good. Because first I have to generate a key, and just like we did last week, you can't parse the key unless you have the older version of OpenSSL, as far as I can tell. So this is what we did last week. This is going to generate an RSA key, 512 bits long, print it out, and then parse it so I can see the components inside there. So there we go. All right. So here's the RSA private key. Here it is in this PEM format, which is the way you normally put it in for machine reading, but that's not good for me. And here it is broken out. So this is N, and then E, and I think this is P and Q. And I've got a chart here to show you what they are. Yep, N, E, D, P, and Q. And remember, N is the modulus. It's the product of two prime numbers. Those prime numbers are P and Q. So P times Q is N. E is almost always this number, which is 65,537 in 60,567 in hex, and D is the decryption key that goes with E. So there's some other things down here that we don't really care about that come from this. But anyway, that's the numbers. So now I'm going to generate the public key. Now this was the private key, and the private key includes all the information. The public key, of course, includes only N and E, and that's what you tell other people. They can use that to send you secret messages, and you can read them and nobody else can read them because you have to know D, which you calculate from P. So this will make the public key. Right? And there it is. There's the public key. This is N, and that's E. There's one form of it. You have N, which is this long 512-bit number, and you have E, which is always 65,537. Or you can also put it in this base 64 encoded PEM format, which is the way most software would like to use it. All right. So now we're going to use E and D, and we're going to generate an RSA signature. So I think I'll do just what I told you to do here. I'm going to make a text file. All right. And I'm going to get E, and I need N, E, and D. So let's go here. N was this one. I'm just going to copy it. So N equals 0x that. That's hexadecimal. All right. And E equals 65,537. And D equals, let me get my diagram. It is NED. Okay. So NED. All right. And putting it here. Okay, D. Nope, somehow it's not working. Oh, it's not coming up. When I go to it, man, weird computer problems today. Maybe I can get to it down here. Just try and get rid of this stupid green bar in the way. If I click this, does it work? Show all windows. There it is. Okay, man. Everything is very messed up today. And maybe I can't do it. I can do it without using a notepad, and I guess I'm going to do it without using a notepad because it's crashed on me. All right. We'll see if anything about my machine is going to work long enough to accomplish anything. We will find out. Anyway, the point is, after we have generated a public and private key, now this is what we're going to do. Here's an RSA signature. The way your RSA signature works is you have a message. The message is X. And then you calculate X to the D mod N, your decryption key. That's a secret known only to the author. And then you send that along with the message. And anybody that wants to verify it can take the signature to the E mod N, and they would get the original message if the message is unaltered, and that proves that it hasn't been altered and you signed it because only you have the secret key D. That's the idea. So I'm going to do it here in a Python environment. I'm going to do this stuff to make the message. All right. So let's go to my bash console. Let's run Python. All right. Now, I create a message, which is hello from your name. And make this a little higher in the room if I can. I don't know if I can get any part of it, so let me have it. Maybe I can't. Might be able to grab it up here. There we go. All right. So this is the message. Hello from your name in bytes. So here it looks like in hex. 38 bytes of hex. That's my message. Now let's see if I can get this thing to get out of the way. All right. Okay, now I'm going to sign it. So I have to have N, E, and D. So I'm going to, and then after I have it, I take X is the hex version of the message. And then I calculate the signature, which is X to the D mod N. That's what this does. And then I put that in hex and print it. So that's what this will do. Now, as written, it's going to use some demonstration values that I generated long ago, but now I want to do it with my values. So I guess since I can't use my text editor, which has crashed along with everything else crashing today, I'll have to do it one at a time. So this is N. All right. That's N, and N was this. So I copy it here. All right. And I paste it here. And it got a carriage return in it. All right. I'm going to need to shrink the font down to where it doesn't wrap. Is that going to work? That is not going to work. Well, then I really need my text editor to work. I don't know how to do this with a text editor. I'll try forcing it to quit and restarting it, see if I can make it work. All right. All right, let's see if I can get my text editor to work, because I do not know how to build this stuff without a text editor. Try and get this stupid thing out of the way again. All right. Well, looks like it won't even launch. It's trying to launch. Let me try adding power to this machine and see if that makes it happier. Well, getting to the point where I'm going to have to give this up and do it another day when something is working. We have trouble with Google, trouble with the text editor, and just a ridiculous amount of trouble today. Perhaps it comes from running Zoom and Twitch on the machine. It looks, well, I could maybe use the stupid built-in thing text edit. I think it's going to be painful, but the built-in thing, there are a couple of Notepad. The problem is it's WordPad. Okay, it doesn't, it puts formatting in, so I might get in trouble, but I'm going to try using this thing because my other app is not working. And I don't know if there's a zoom function anywhere. View, zoom in. All right. All right. Let's try this. If I have a text editor, I can do this the logical way, which is get this garbage out of the way. Get this garbage out of the way, I said. All right. Which is to copy this and then replace the contents. So this is the stuff I'm trying to build. All right. And I guess I don't want to zoom in that much. View, zoom out. All right. There's the stuff I'm trying to make. And I thought I could make it wider. Up here, maybe. Will that thing move? That thing will not move. All right. Let's see. Is there any way to make the window wider? View, format. These things up here would seem to serve the purpose of delineating the end of the page, but it only goes up to 11 inches. Well, can't zoom in or out properly. I think these carriage returns are still going to hurt me. Let's just try this. Let's see if it'll take this in that Python environment. I think it probably won't. Control C, paste. Oh no, good. It works. Okay, good. All right, then I can let the wraparound happen and it doesn't matter. Okay, so now finally, I can go back to here and I can get n. Here's n. I copy it. All right. Then I go back to here and I replace n. All right. Now I go here and all right, I got n, I got e is fine, d is what I need. D is going to be the third number. Okay, that's n, e, d. All right. There. So I have my value of n and my value of d, and now I can calculate the signature. What's that? What? Okay, good. All right. So let's see if I can run this stuff in that Python environment. And D is not defined. Okay. E works. It didn't like D. Actually didn't get, the D had a wrapping problem. Okay, I'm going to have to stop the stream and restart my machine and see if I can get a text editor that works working here, because I'm getting nowhere. Oh, now it's finally moving. Okay. Boy, I think this is probably network problems on the internet, because apps can't launch on a Mac without sending data to Apple. All right. So anyway, now I seem to have something working here. Let me try it again. If I go here, I have to get this stupid thing out of the way somehow. And all right, I'm going to try it again. It's going to be a pretty messy video, but it is very often the case that you have to struggle and try things over and over to get anything to work. I had a student saying, these projects don't work. I keep hitting trouble. And the real learning is coping with the trouble. There's always trouble. Nothing ever works the way it's supposed to. You have to. All right, there it is. And it looks like it's got a bad carriage return. So it's supposed to be AB. I can delete it. There, now it's AB. Okay, good. So there I got the first line of this garbage right. Now all I have to get is D. This was N, E, this is D. So I can copy it. I can paste it in here. And I can fix the carriage returns. There. Now I've got good Python code. This will define N, E, and D, and this will calculate the signature of the X, which I defined previously. So let me just make sure I did that. If I print X, yeah, there it is. X is the number which stands for my message, like hello from your name or something. So I should be able to do all this stuff with N, E, and D, and there it is, this horrible mess, 0xCC, garbage. That is the signature. And it's in a variable called S. And you can verify the signature is correct here by taking S to the E mod N, and that should take you back to the original message. And here it does. And you see, there it is. It turns back into hello from your name. So the signature can be decrypted with the encryption key, which is public, and verify that this message was signed by a possessor of the private key. So this is the point of a RSA signature, and it has the legal force of a signature made with a pen on a piece of paper, thanks to Bill Clinton's Digital Millennium Copyright Act in 1998. This is what made commerce possible on the internet. But now we're going to do a forgery. You can do an existential forgery attack, and here's how it works. You choose a signature, and you can create a message that will have that signature without knowing the private key, because all it has to have is this property. And so I'm going to make a signature of just 0xF, a number that's almost all zeros and has an F at the end. And then you set that to the signature, and now you calculate the X, S to the E mod N, and that is the plain text that matches the signature. Now, of course, it's going to be garbage. It's not going to be printable or anything, but you can see it. This is going to be a forged message with a valid signature that I've created without knowing the private key, which is a flaw of the system. Now, what is this XA garbage? All right. XA is bytes from hex, a non-hexadecimal number found in XT. All right. Let me see. What's the problem now? Print hexadecimal string, POW S to S is 0xF. All right. Well, let's go step by step. S is 0xF. Let's see if it understands that. Control C to clear this garbage. Okay. All right. If I print S, it is really 15. Okay, it understood that. So now I should be able to take pow of S to the EN. Let's see if I can do this. All right, let's see what XH is. Oh, it's got a 0x in front of it. Okay. So I trim it. This should do it, XH2 colon. So that should work, and this should work, and that should work. Let's see. That should get the 0x out of it. And it did. Okay, that's the trim hex string. Okay. Now I'm going to do bytes from hex xt. Non-hexadecimal number at 127. Position 127. Well, let's see. That's xt is probably something like a carriage return or something again. Let's print xt. Length of xt is 127. Xt sub 0. Okay, xt sub 126. Xt sub 127. It does seem, no, it's empty. There's nothing there. So this shouldn't have ever gone there at position 127. This is some weird Python problem. I'm having an unbelievable number of bizarre problems tonight. It's reaching beyond the length of the string and finding a non-existing value and freaking out about it.
The period at the end of the whole string.
I did that. 126 and 127 are here. 126 exists and it's really C. 127 does not exist. And yet this thing thinks it's trying to go to 127. I may, it's really just the plain text. What I can do is I can just throw away the last bit of it. Let's see if this works. I'm trying to do this. How about if I do 0 colon 126? See if it'll do that. All right, it'll do that. I might miss the last letter result because all I'm trying to do is print out the results. And I don't know why this Python has decided to reach beyond the end of my string, but there it is. This is what I wanted to show you. Here's the ASCII message. This message has a signature of F. And this is what the message looks like. Just stars, unprintable characters, occasional printable characters. It's a sort of meaningless gibberish of binary, but it does have the property that it matches the signature, and that's wrong. You should not be able to forge a message and a signature without knowing the private key. That's called the existential forgery attack, for what it's worth. And if you have your own Python installation, it should work a lot better. Or if you can use Google Colab when it works, it should work better.
Which step that it compares to the signature?
I didn't test it because it's obviously going to work because you generated it here. You generated the plain text by taking the signature to the E. So you know it, that's what it is. This is the step this is the verification step. This is where you take the signature and verify the message. And I didn't feed in a real plain text message ever. I've created a signature and message that match. That's all. And you can do that without knowing the private key, as long as you're willing for the message to be unprintable junk. But that's often enough because implementations will often accept a valid signature as proof that you've logged in, proof that you have authorized, that sort of thing. So there's a couple of challenges here. You're going to do that, and I'm going to stop this recording. And